Hello everyone, so in this video we will learn how to calculate the NDVI and the NDWI. So the NDVI is the normalized difference vegetation index and the NDWI is the normalized difference water index. So these are two of the most common spectral indices that we use in remote sensing. Now there are two ways to compute this. So the first one is using a built-in function, the normalized difference. Okay, so if you have an image object, then you can use this function. So we will demonstrate that later. And the second one is the dot expression method, still under the image object. So you can, if you have a specific formula or a customized formula that you want to use, then you can input the expression there. Okay, so we will use those two. Okay, so let us just take a look at briefly discuss the code that we have here. So all of these have been discussed in previous videos. So if you forgot how to do this, then you can watch those previous videos. So the first one is we imported two data sets, the Sentinel-2 dataset and the political boundaries, specifically from the Philippines. And then we created a geometry. So we named it ROI. And then we extracted the bye-bye city shapefile there. And then we converted it into a geometry, okay, geometry object. And then the second line of code right here is we filtered the Sentinel-2 data. So using the metadata, cloudy pixel percentage, and then the date. So this is from January 1 to September 30, 2021. And then the bounds, we are going to use the geometry, the ROI. And then we created the median image of this image collection, this filtered image collection. And then we also clipped it using our bye-bye city shapefile here, using our ROI. Okay? So let us now proceed to calculating NDVI. So we are going to use the built-in function. So we're going to use the filtered clip. Filtered clip, this is an image, right? Filtered clip dot normalized difference. Okay, so our arguments here should be the names of the bands that we are going to use. So for NDVI, as you know, we are going to use the near infrared, which is band 8 and band 4. Okay, so if you're wondering where this B8 and B4 names came from, so you can just view the names of these bands in the Google Earth Engine catalog, or you can also use the inspector. So it will give you some properties right there, and it will also give you the names of the bands. Okay, so let's try to output this result. Okay, that add layer. So that is NDVI. So let's try that. Set to run it. See what happens. So here we have our result. Okay. So the darker areas there have a lower NDVI value. So as you know, the NDVI values range from -1 to 1. So if I click there using the inspector on the top right here, if you select that tab, you can find the pixel value. So that is -0.107. If we click on the brighter sides here, then we will have 0.766. Okay, so normally we will use a better visualization for this. So let's create a visualization object. Let's name it NDVI Vis. Okay, so we will specify the minimum value. The minimum we will use 0, and then for the maximum we will use 1. And then for palette, this will be their color palette. So a list here. So let's use white and green. Okay, because this is vegetation. You can also add another color. So the white here will be the values, the pixels with pixel values closer to 0, and the max, and then the green here will be the values, the pixel values closer to 1. Okay, you can also add another color here, so it will be sort of like a spectrum. Okay, so we have the NDVI Viz. Okay, so let's see what happens if we run this, if we entered it correctly. Okay, so there we have it. So it's really cool, right? So we have the green area here have higher NDVI values, therefore we have more vegetation there. Okay, so let's try to see it. I clicked on the green area, so let's see the NDVI values. We have 0.818, oh, very close to 1 already. Okay, so there you have it. That is the first way to compute the NDVI. So let's use the other way. So the other way is using the expressions function. So var, let's NDVI 2, okay, and then we're still going to use this filtered clip image, and then expression. Okay, expression. Okay, so that's it. So the arguments here, so first we need to have a string. So this is the formula that we are going to use. So for NDVI, so you will use near infrared. So bear with me here. I will explain why I'm putting NIR there instead of band 8. So minus red, and then divided by NIR plus red. Okay, so that is the formula for NDVI, right? And then the second argument right here is a dictionary of what NIR and red means. Okay, so I'm going to put here NIR and then a colon, and then we will select the bands, filtered clip dot select. Okay, and then we will select our band 8. Okay, and then so that is our near infrared, and then we also have our red. Okay, so filtered clip dot select, and then this will be band 4. Okay, so if we so those are the arguments again. So we have an expression there in a string data type, and then we have a dictionary, so what the NIR means, and then what the red means in our string. Okay, right? So let's try to display this NDVI2 using the same visualization parameters. Okay, so let's run it. Okay, so as you can see, we have the same result. Okay, it's really cool, right? So let's now move on to calculating the NDWI. Okay, so basically we are going to use the same two methods. So we are just going to copy it. We're just going to rename the variables here and also the bands. Okay, so we are for NDWI we are going to use band 3, that is the green, and then for band 11, that is the what do you call this, SWIR. Okay, and then for the NDWI2 here, SWIR1 NDVR, so we are going to use here green, and then this will be SWIR1, and then let's just copy it. So we have our green here, and this will be band 3, and band 11. Okay, so let's try to load these indices. So let's start with NDWI with the built-in function. Let's see what we get. Oh, I forgot, we were supposed to use another another visualization here. So let's create another visualization parameter, visualization object. So for this, we're going to create, let's see, ndwi vis. So the max, so let's just set it to 0.5. So this is, I think, the best ranges for this, but you can also experiment it. So it's best if you experiment it to see what happens. And then we will use blue because this is water we are trying to determine here. Okay, so let's try it again using this visualization parameter. So ndwi vis. Okay, so let's try to run it again. Oh, I spelled it wrong. Okay. My internet is really slow. I'm sorry for this. So as you can see right here, guys, so this is our, so as you can see, there are, of course, this is the shore, and also in the parts of the river here you can clearly see bodies of water. So it's very nice. Okay, so let's try to use the ndwi too. So let's see if we get the same result. Oh, so there's an error. Let's see. NIR green. What's this? Oh, wrong spelling. So this is supposed to be only green. Okay, so let's try it again. See if it works. Okay, so there you have it. Very cool. Okay, so just to recap, so we calculated the NDVI and the NDWI using two ways. First is the normalized difference built-in function, and then also we use the expression where we really enter the formula for NDVI and NDWI. Okay, and we also use this palette for how to color our output. Okay, so there you have it. So I hope you learned something new in this video, and I will see you in the next videos.